Hello everyone. In today's lecture, we are going to learn about insertion sort. So first we will see what is insertion sort. It is a comparison sorting algorithm that builds final sorted array one at a time. It is efficient for small list or arrays, much like other sorting algorithm. In practical, it is more efficient than other sorting algorithms such as selection sort or bubble sort. It is much better than them. If the array is already almost sorted, of half of the elements of the array are sorted, then insertion sort is the best to apply. If the array is not sorted at all, it is a random array is taken, then quicksort is better. But after quicksort, if the array is almost sorted, some of the elements are already in the sorted order, then the insertion sort is the best algorithm to apply. And it is always better than selection sort and bubble sort. It is better because it is adaptive, efficient for data sets that are already considerably sorted. If the sum of the elements are already sorted, they are already in the order, then this is the best algorithm to apply. Then it is a stable. It does not change the relative order of the elements with equal key values. For example, if any array is having same key elements, suppose 10, 12, 12 and 13. So when you apply insertion sort in this algorithm, this will be considered as, suppose, first element A element, will be considered the B element, C element and D element. Okay, so now after sorting also, means after applying this insertion sort also, this whichever 12 was there at B position, it will remain there only, and this 12 will remain at C position only. They won't get changed. Okay, this one won't come over here, this one won't go over there. So it does not change the relative ordering of the elements with equal key values. The values are equal. In this array, 12 is same. It is there at two places. So it will remain at their place only. It won't change after sorting, after applying insertion sort. That's why this algorithm is called a stable algorithm. The next is does not require additional memory space. After sorting also, the same memory space is occupied, no extra space is required. So it is called as in-place sorting algorithm. Now we'll see the insertion algorithm steps. First step is it starts by making second element of the array, that is element at index 1 as j. Then compare the element with index 1, that is j, with the elements before it. So element before index 1 will be index 0 and it is considered the I. So jth element will be compared with the ith element. If the element at index 1 is less than element at index 0, then exchange those elements. And if the element at index 1 is greater than element at index 0, then no change. So then compare element at index 2 and consider it as a j now of array with element to its left and insert it at the correct position. So repeat above step until the array is sorted. So we'll see this algorithm with the example. Now this is an example. Original input array is given, which is not in sorted order. It is in some random order, as you all can see. 32 is there at first place, then 23, 12 and 21. So we have to sort this array using insertion sort. So iteration 1, or you can say pass 1, what we have to do, as I told in the algorithm just now, element at index 1 has to be marked as j. An element at index 0 has to be marked as I. So this is a marker, suppose. So now we have to compare the j element with the I element. So 32 is compared with 23. Now if j element is less than I, then swap. Okay, you have to swap a of I with a of j. Now in our case, a of j is less than a of I. You can see a of j is what? 23 and a of I is what? 32. So 23 is less than 32. So we have to swap. So 23 came on 32's place and 32 went on 23's place. So at the end of so this is the end of iteration 1. So now in iteration 2, we have to increment the I by 1 and j also by 1. So now I will reach, initially I was at 0th position. Now I will be at 1 position and j will be at position 2. See, now I is at 1 position and j is at position 2. So now wherever the I is there you have to put the marker like this. So we can consider this entire part as a sorted part and this part as unsorted part. Okay. Now compare the j element, that is a of j, to compare with a of I. If a of j is less than a of I, then swap a of I with a of j. Now a of j is 12 and a of I is 32. So j is less than, well, where j is pointing, so 12 is less than 32. So we can swap. So 12 will come at 32's place and 32 will go at 12's place. Now we have to, unlike bubble sort and selection sort algorithm, now we have to decrement the value of and I, because every time we are comparing with the sorted part, unsorted part and sorted part we are comparing. So sorted part, this is a unsorted part. So now again you compare 12 with 23. Now 12 is less than 23, so swap it. Whenever the value of j is less than I, you have to swap them. So 12 will come at 23's place and 23 will go at 12's place. So now at the end of iteration 2, we got the 3 elements in the sorted position. So these 3 elements are sorted and this last element is unsorted. So in the iteration 3, I will be at position 2. See, if you see in the iteration 1, I was pointing at position 0 and j was pointing at position 1. In iteration 2, I was pointing at position 1 and j was pointing at position 2. Now in iteration 3, I will point at position 2 and j will point at position 3. So marker will be where the I is pointing, there the marker will be there. So your marker will come now. So now this is called a sorted part and the last part is unsorted, last element. So now compare 21 with all the sorted element, that is 12, 23 and 32. One by one we have to compare. So first it will compare with the where I is pointing. So 21 will be compared with 32. Is 21 less than 32? Yes. So 21 will take the place of 32 and 32 will go at 21's place. So now decrement the value of j and I by 1. So j will come at the position 2 and I will go at position 1. Again compare 21 with 23. Is it less than 23? Yes. So 21 will take 23's place and 23 will take 21's place. Again decrement the value of I and j. So I will take position 0 and j will take position 1. Again compare. Is 12 less than 21? Is 21 less than 12? No. 21 is not less than 12. J value is not less than I value. So they will remain as it is, no change. So if you further decrement the value of I and j, I will go beyond this and there are no elements over here. So there is no point in decrementing I and j further. So we got the sorted array at the end of the iteration 3, that is 12, 21, 23 and 32. So basically in insertion sort, we have to keep the marker. Initially the marker will be at the after first element where I is pointing and j will be pointing to the next element after I. So in next iteration, just increment the value of I and j by 1 position and put the marker wherever the I is pointing. So every iteration you have to do this till you reach at the end. So this was all about the insertion sort example. Thank you.